All right, today we've got a weather report for you, but it's not from anywhere on Earth. Nope, this forecast is coming from deep, deep space.
You know, this quote from space.com just sets the mood perfectly. It comes from deep space where a lonely world drifts without a sun. We're talking about a place in constant twilight, a rogue world just floating all by itself in the cosmos.
So what is this strange and lonely place? Well, let's get properly introduced to the subject of our cosmic weather report, a world with the catchy name of SIMP 0136. Let's pull up the stats on this thing. Cosmetically speaking, it's practically our neighbor, just 20 light-years away. And like we said, it's a rogue, no sun. It's also a baby, only about 200 million years old. But check out its rotation. It spins once every 2.5 hours. Can you even imagine a day that short?
So what exactly is this thing? It's not really a planet, but it's not a star either. Astronomers call it a brown dwarf, and probably the easiest way to think about it is as a failed star. See, it started forming just like a star would, from a giant cloud of gas, but it just never got big enough to kickstart that nuclear fusion that makes a star shine.
And this chart right here, it really lays it all out for you. On one end, you've got planets, right? They orbit stars, they're not big enough for fusion. On the other end, you've got stars. They're massive, they fuse hydrogen, they make all that light and heat. Brown dwarfs, they're in that fascinating, murky middle ground. Too big to be a planet, too small to be a star.
So you have this mysterious world, and to figure out what's going on with its weather, astronomers had to call in the big guns. This is where our detective enters the story, the James Webb Space Telescope. So how did Webb crack the case? Well, it basically just parked itself and stared at SIMP 0136 while it did its super fast spin. And its incredibly sensitive instruments picked up these teeny tiny changes in the world's brightness. That flickering light held all the clues scientists needed to build this absolutely unprecedented weather report.
Now, for a long time, the main theory about this flickering was pretty simple. Scientists figured it was just patchy clouds. But we're not talking about fluffy white water clouds. Oh no. These were thought to be clouds made of hot, molten, sand-like stuff called silicates. The idea was, as the world spun, these patches would whip in and out of view, making the light flicker. Seemed plausible, right? Well, Webb's super precise data came back, and the cloud theory didn't quite add up. The numbers just weren't matching the models. So that left astronomers with a huge, hanging question. If it wasn't the clouds causing all this atmospheric drama, what on earth was it?
And this is where the story gets really good. The answer wasn't down in the clouds at all. It was way, way higher up, and it was a total surprise. So here's the twist. Webb's observations showed those silica clouds were actually remarkably stable. They weren't breaking up or moving around enough to explain the flickering. No, the real action, the source of the whole mystery, was happening much higher in the atmosphere.
And when I say action, I mean it. The team found a layer of air way up high that was nearly 570 degrees Fahrenheit, that's 300 Celsius, hotter than any of the models predicted. I mean, think about that. A massive, unexplained heat source on a world with no sun to warm it up.
So what could possibly generate that kind of intense heat? The answer is just as beautiful as it is powerful. Auroras. And we're not talking about your everyday northern lights. We're talking about auroras supercharged by a crazy strong magnetic field.
So here's the breakdown of how that works. On Earth, our magnetic field funnels particles from the sun to create auroras. On SIMP 13C, a much, much stronger magnetic field grabs charged particles and slams them into the atmosphere so hard that the collision doesn't just create a beautiful light show, it literally pumps a massive amount of heat and energy directly into those upper layers.
But wait, that's not all. The auroras weren't the only thing Webb spotted. Deeper down, way below the clouds, it also picked up on these subtle little temperature shifts. The prime suspect for that? Giant storm systems. Maybe something like Jupiter's Great Red Spot, just churning away as this world spins like a top. Okay, so we've got a sunless world, heated by auroras, with giant storms. It's an absolutely incredible discovery. But why does this one weird little world actually matter? Well, it turns out this lonely rogue is giving us a unique window into countless other worlds. Here's the really clever part. When we try to look at a giant exoplanet orbiting another star, the star's light is just blinding. It makes it almost impossible to see the planet's atmosphere. But a rogue brown dwarf like SIMP 0136? No star. It's an unobstructed, perfect laboratory for figuring out the atmospheric physics of these giant worlds. And don't just take my word for it. Johanna Voss, one of the scientists on the team, put it perfectly. She said, understanding these weather processes will be crucial as we continue to discover and characterize exoworlds in the future. Basically, what we learn here helps us understand worlds everywhere.
And that really just brings us to the final, mind-bending question. We've just seen a world with no sun, floating alone in the dark. And yet it has this incredibly dynamic atmosphere, superheated by auroras and stirred up by giant storms. So it really makes you wonder, if a lonely world can have weather this wild, what kind of absolutely incredible things are happening on the planets that actually do have a star?
If you're ready to explore the hidden truths behind mysterious sciences, subscribe now and become part of the enlightened society.